All right, this video is on section 5.7, integrating natural log functions. So this is our Calculus 2 course, section 5.7, integrating natural log functions. Theorem 5.21 just shows you the integration of a natural log function. In other words, if we're trying to integrate 1 over x, the answer is once you integrate that, you get the natural log of x plus a constant. Now, we could also use the same formula with u's or du's if you're going to integrate by parts. So if you have something underneath the fraction that's more than just an x, and you want to classify it as u, and then take the derivative of that u, then we're okay. Then you can use the du function. Here, here we have x, and the derivative of x is just 1, right? The derivative of x, taking the derivative of x, it's just 1. Here, u, we can classify anything we want with u and then take the derivative of u. So that's just the difference between the formula that has u and has x. When you have u's, you usually have something a little bit more complicated than just an ordinary x. All right, so let's take a look at the first problem. Trying to bring all this. Okay, so integrating 1 over 4x minus 1. So we're definitely going to be using integrating 1 over u du formula. So we're going to be using this because there's more than an x here. So what we do is we classify this as u. We did it right here. U equals 4x plus 1. And then when you take the derivative of u, the derivative of 4x is just 4. The derivative of 1 is 0. So we get 4 dx. So putting this into our formula, we have here's our formula. I'm going to write it down again. Integrating 1 over u. We said u was 4x plus 1. And then du is 4 dx. Now we have to have, do you see this extra 4 is kind of in the way. If you look at this 4 is kind of in the way. So we have to offset it. We have to cancel this 4 out. One way of doing that is just by putting a 1/4 in front. Now I have 1/4 times 4, and they cancel each other out and turn into 1. So this changes. So the problem now changes to 1/4 in front There's the 1/4. And here's u, 1 over u. And this is du. du's right here, 4 over x. So when we integrate 1 over u du, we get, we're just going to integrate this part, we get the natural log of u plus c. And don't forget, there's this 1/4 sitting in front. Okay, so we got that integration formula. Don't forget from 5.2.1. There it is. 5.2.1. Integrating 1 over 1 over u. I'm making a big mess out of this, ain't I? Integrating 1 over u du is just the natural log of u plus c. So this is our answer down below, but there's a little bit more we need to do. So we can't classify this as an answer because we can't have u's in our answer. So our final answer is 1/4 natural log of u. U happens to be 4x minus 1 plus c. So this is the answer that we record. You can't have u's in your final answer. So you have to convert all the u's back to x's. All right, let's take a look at the next one. That was kind of a, maybe I shouldn't have had all this other stuff written down at first. Okay, in this problem, it says find the area between 0 and 3. We'll do that, but we're going to integrate this. So let's just look at integrating x over 2x plus 1. Well, if you look at this, let's call, we're focusing on integrating 1 over u du. We're focusing on this. Don't forget the formula is the natural log of u plus c. That's the answer. So let's change u to x squared plus 1, and then the derivative of u is 2x. Okay, so if I here's our formula once again, and we are integrating u 1 over u and then du. So this is the same thing here, 1 over u and du. Well, du in this case is 2x. So if I have a 2 here, I can only integrate this. I can't have other numbers there. So if I have that 2 there, I have to put a 1/2 here to cancel it out, to turn it into 1. So now I am integrating. I'm going to bring it up here. I'm integrating 1/2 1 over u du. Do you see the du is 2x and it cancels out with this 1/2? So when I do that, I end up with 1/2 times the natural log of u plus c, because this equals that. And the last thing I got to do, 1/2, oh, I'm running out of room down there. 1 over 2 natural log of u. We said u was x squared plus 1 plus c. So that's what we end up with. All right. Let's try the next one. Oh, I didn't. I apologize. I didn't finish. We're integrating from 0 to 3. We had 1 over u du 1/2. So we have 1/2. And when we integrated, we had the natural log of x squared plus 1 and we integrated from 0 to 3. So first we're going to put 3 into the function. We're going to start off with 1/2 times the natural log. Put 3 in there. Let's just do it. And then we're going to subtract the natural log of 0 plus 1. So this is 1/2 times the natural log of 10 minus the natural log of 1, and the natural log of 1 is 0. So our answer is 1/2 times the natural log of 10. All right, let's try the next one. All right, so I give you a clue on this one. It says use long division. Now, the reason why you're going to use long division, look, the powers are the same. If you made this bottom, let's say you're doing natural logs, u x squared plus 1 du is 2x. There's no, 2x and x squared is on top. You can't change this to du anyway. Do you see? There's no way of doing it. So this is a fraction. Let's divide it. Let's use long division and divide it. So, oh no, got to use some algebra skills. X squared plus x plus 1 divided by x squared plus 1. Well, x squared goes into x one time. So I have x squared plus 1. Okay, and I'm going to subtract it. These cancel out. These cancel out. Well, subtract the whole bottom. So distribute the negative there. That cancels out, and we're left with x. And 1 minus 1 turns to 0. So that cancels out. It turns to 0. So this is what we're left with. Do you see? We're left with 1 with an x remainder. In other words, our answer looks like this. 1 plus x as a remainder, x squared plus 1. And you always put the divisor underneath the remainder. So this is the answer when we did long division. So in other words, these two are the exact same. These two, this and this are the exact same. One is just done division. You use division on it. So we're going to do 2 integrations. You have to integrate 1. If I would have wrote it as a 1. You have to integrate a constant 1, and you have to integrate x over x squared plus 1. So I'm going to erase the rest of this stuff on the right. Well, integrating 1 is easy. The answer is just x. And you can get that from your, that's something we learned earlier. You can get that from your integral sheet also. Integrating a constant is the constant times x plus c. And now integrating this part, so we're just going to do this separate. And u is x squared plus 1. Do you see the bottom? I'm creating the bottom as u because the top is 1 power less du is 2x. So we are integrating u and du, which is 2x. So since we have a 2 there, we have to put 1/2 here to cancel that out. Because it's like integrating 1 over x and then dx. So this is what we end up with. Now I can write it as 1/2 integrating du over u, because the du has an invisible 2, it has a 2 in there, and this cancels out with it. So then this becomes, don't forget about this x here. So there we did that already, but let's just concentrate on this. So it ends up being 1/2, and this becomes the natural log of u plus c 1/2, the natural log, and u is up here, x squared plus 1 plus c, and don't forget about this x we had in front. So this is what our answer would look like. So that's kind of tricky. You'll actually have one of these on the test, I'm sure. I think I tell you to use long division, but you can recognize it. Look, the powers are the same, so you're going to do long division. Or if the top power is larger than the bottom, you'd have to use long division and somehow. So it's not too bad once you remember how to do long division. All right, let's take a look at this one. This one's a little trickier. And I have some clues here. Once again, we know about integrating du over u. If I label u as x plus 1, I mention it here, then the derivative of x plus 1 is just 1. So, I mean, if you look at this, let's take a look at that. If this ends up becoming u, because x plus 1 is u, this ends up becoming u squared over 2x over du. I'm just going to put the 2x right now because that's the du. So yeah, u squared, that we don't have an integration for that. We don't have that u squared. We have du over u, not over u squared. Okay, so let me erase this part. Actually, I can clear the whole thing. The hint that I give you here is if u equals x plus 1, if I bring this 1 to the other side by subtracting 1, u minus 1 equals x. Then we have this right here, x equals u minus 1. So we know u, we know du, and so now we know x. So this is kind of important. I'm going to integrate this now down here. On top, I have 2x. On bottom, I have u squared. Remember, there's u, and it's u squared. So instead of x, I'm going to put u minus 1 in there, so they're all u's. 2 times u minus 1 over u squared. Do you see? We just changed this so we can find out what x is, and we changed the x to u's. I'm also going to change it again. I'm going to bring this 2 out in front. It's a constant, so you can bring it out in front. There, it's a multiplier, so it comes out front. So I end up with u minus 1 over u squared. And what you have to recognize is, wow, I still can't do much with this unless I see a u and a u squared here. I see something that could be forming from that, and it takes a little practice. This is 2. And we're going to integrate u over u squared minus 1 over u squared. We took this u squared. And we put it underneath both of those. I know you can't see that. That's the yellow. We took that u squared and we put it underneath the u. And we also put it underneath the minus 1. So now I can integrate this. The bottom is our u, and the top is our du. But give me a second. I'm trying to see what happened here. There it goes, no? So if you look at this, do you see how I have a u and a u squared? Well, one of them cancel. U divided by u squared equals 1 over u. Minus, and I'm going to bring this u to the top, u to the negative 2. By the way, we have 2 integrations here, right? And when you have an add or subtract there, you really have, I broke it into 2 integrations. So the first one is natural log of u. And the second one, we just use regular integration, the power rule. We add 1. And negative 2 plus 1 is negative 1. So here I end up with minus u to the negative 1. Then you put the new power on the bottom. These two change to a positive. Just trying to make room. I'm getting really crowded here. Natural log. By the way, u, don't forget what u is way over here. X plus 1. And this changes to a plus. One over u. And you see this, these two change to a plus, and this is u to the minus 1, which is 1 over u. And I'm changing the 1 over u, the u part, once again. The u part is over here, x plus 1. So the last thing I want to do is distribute the 2. We get 2 natural log of x plus 1 plus 2 times 1 is 2 over x plus 1. And don't forget the plus c at the end. All right. Let's see what's next. All right. What about integrating? Uh-oh, something just, I don't want that. What about integrating the tangent of x? Well, if we look at our formula sheets, there's no formula for integrating the tangent. Well, there is. Turns into natural log of secant x. But there's another way of looking at it. So I guess there is a formula for that. I don't know why. Okay, so what we showed here, that we just changed it. Let's see how this looks. We just changed it. Tangent is sine over cosine. And if we're sticking with the natural log rule, since we're in that section, then we're going to call the bottom, once again, u. U is the cosine of x. The derivative of the cosine of x is negative sine x. So once again, if you look at that u, du, du, our u is the cosine of x, but du is the negative sine of x. So that negative changes everything, because we don't have, the original problem doesn't have a negative there in it. So we have to, anything that changes, we have to cancel, or we have to fix that negative so it stays as a positive, because that's an extra negative, just like if it was an extra whole number. So if we put the negative in front, that counteracts this negative sine x, the negative part. The sine x is du, the negative sine x. But if we put a negative in front, negative changes to a positive. So do you see this? If I do this and I put the negative sine x there and the u there, these two will cancel each other out, because that's an extra negative in there that we don't have up here in the original problem. Do you see we don't have that negative? So to put the negative here, I also have to put the negative there. All right, so this is where we're at. And when you integrate this, you get the natural log of u plus c, and there's a negative in front. So my answer is negative natural log. U is cosine x, right there, plus c. And we have one more. All right, what they show is this is a little different. And once again, a lot of these just take homework practice, lots of practice, not only the homework, but in the examples in the book, taking a look at it. This is an example from the book. If you look at this, these two are the same, right? Just want to make sure everybody understands they both mean the same thing. This is 1 over x. 1 over x is the same thing as saying 1 over x times 1 over the natural log of x. And you could actually put it on top. It doesn't matter. It's the same. They mathematically, they're the same. So these two mathematically are the same. That's kind of important. So if we go back to our u's and our du's, let's call u the natural log of x. And we know the derivative of the natural log of x is 1 over x. So what we have here, I call this bottom u. And look, the derivative of u is 1 over x du. So we're done. There's nothing extra to add or anything like that. This ends up equaling the natural log of u plus c. Well, what's u equal? U equals the natural log of x. So it looks a little weird, but this is the answer. It's the natural log of the natural log of x plus c. You could put an absolute value symbol in there also. Doesn't matter. And that's what you get. I think that was the last slide. Yeah. Okay, I hope this video helped. Let me know if you have any questions.